Welcome aboard, where aviation concepts become simple. From instruments to aerodynamics, we make exam prep clear and cockpit learning faster. This is StudyKwik Aviation.
Welcome to StudyKwik. In this lesson, we are going to look at the principle of operation of the pressure altimeter and how it is calibrated. We will also explore the simple altimeter, the sensitive altimeter, and the servo-assisted altimeter. The pressure altimeter is like a pressure gauge. It senses changes in static air pressure and, through calibration, shows these changes as altitude. To understand this, we need to consider how the atmosphere works. The static air pressure at any point depends on the weight of the air above. Imagine a tall column of air rising from the Earth's surface. The higher we climb, the shorter the column above us becomes, and the lower the pressure. By measuring this pressure, the altimeter measures altitude. But the relationship between pressure and altitude is not linear. Weather systems affect pressure. For example, traveling from the UK to Iceland at sea level, pressure may change from 1036 pascals to 996 pascals. Temperature also affects pressure. These variations complicate calibration, so the International Standard Atmosphere, or ISA, is used as a reference. ISA assumes mean sea level pressure equals 1013.25 hexapascals, temperature equals plus 15 degrees Celsius, density equals 1.225 kilograms per meter squared. Up to 36,090 feet, temperature drops 1.98 degrees Celsius per 1,000 feet. 36,090 feet to 65,617 feet, temperature stays at negative 56.5 degrees Celsius. 65,617 feet to 104,987 feet, temperature rises 0.3 degrees Celsius per 1,000 feet. With ISA, pressure for any altitude can be calculated. Altimeter readings in the lab are checked against these values. Errors are listed as correction tables. But note, since altimeters are calibrated to ISA, they only show correct altitude when ISA conditions exist. Real atmospheric conditions vary, so pilots use pressure settings to adjust. Let's look at how the altimeter works. Static pressure is fed into a sealed instrument case containing an aneroid capsule. As altitude increases, pressure decreases. The capsule expands, moving linkages, and the pointer shows a climb. In descent, the capsule compresses, and the pointer moves down. A temperature-compensating device in the linkage reduces errors from thermal expansion or spring tension changes. The simple altimeter has a manual setting knob. Setting QFE indicates height, and setting QNH indicates altitude. Accuracy is improved with jeweled bearings, reducing friction. Some include vibrators to reduce inertia and improve response. Many sensitive altimeters use 3 pointers, one for tens of thousands, one for thousands, and one for hundreds of feet. But this can be confusing and easy to misread. To improve clarity, modern versions use a digital readout for 2 values, keeping a single pointer for 1,000 feet per revolution. Changing the subscale changes indicated altitude, which is crucial for correct flight operations. So, we've seen how altimeters are built, calibrated, and used. These instruments ensure pilots get accurate altitude readings, even with changing conditions. Don't forget to like, share, comment, and subscribe to StudyKwik for more aviation lessons.